In the previous video, I gave you the theory, so now it's your turn to have a go. So so this is me on my motorbike. I'm going to ride the motorbike off the top of the building at 4 meters per second. The height of the building is 50 meters, and I'm on Earth. So so gravity on Earth is let's just say it's 10 meters per second squared. Where should I place my bucket of water in order for me to survive? So you see, when I ride my bike on the building, I will probably follow this path here. Now, if I place the bucket of water here, um, it it, uh, it will be too short. I wouldn't survive. If you place the bucket of water here, I wouldn't survive. You need to place the bucket of water in the right place. Okay, so your job is to find out where I should place the bucket of water. But by the way, this distance here is called the range. Okay, the range is how far you would travel for during your flight time. So well, anyway, this distance here is called the range. The question is, what is the range, or where should you be placing the bucket of water? Okay, so press pause and have a go. Oh well, before you press pause, let me give you a clue. When you follow this path here, the split it into two components. You see, if you drop a cannonball and the flight time of the motorbike here will be the same as the as if you were to drop a cannonball off here. So the flight time here would be the same as the flight time for the cannonball. So work out the flight time of the cannonball. That will give you the flight time of of the motorbike. And when you come to calculate how far or come to calculate the range, well, imagine it as you and your dad are sitting in a car, and you and your dad are driving along at 4 meters per second. Let's say the flight time is, let's say, 5 seconds. Okay, that means that means you and your dad will be driving for 5 seconds. So here 4 seconds. Sorry, in 1 second would have done, you and your dad would have done 4 meters. In 2 seconds, you would have done another 4, which would be 8 meters. Another second here would be 12 meters. Another second here would be 16 meters, and so on. So by you being able to calculate the flight time, you can calculate the range. Okay. So well, anyway, press pause and have a go. Okay. So now we know that the flight time of the motorbike will be the same as the flight time of a cannonball. So when something's free falling, jump to this formula: gt squared over 2. Okay, in this case, g is 10. Okay, so now just visualize it as 10 over 2 t squared. Now this is 5. So you can imagine the above as 5t squared. Okay, h equals 5t squared, and put the well, the height is 50. So put the 50 in here, and this will be this. Find out the time of flight. Well, divide both sides by 5. That will be 10 t squared. So t equals root 10. Okay, so the flight time will be root 10. So you would probably jump to your calculator. Hang on, calculator. Just find out the square root of 10. So square root of 10 is 3.16. 3.16. So my flight time is 3.16. Now imagine you and your dad sitting in the car here. And you remember you're driving 4 meters per second. And the flight time is 3.6 seconds. So let's see, 1 second I would have traveled 4 meters. Another second I would travel another 4 meters. Another second I would travel another 4 meters. And then I've got a bit here. So basically, I'm just going to get 3.6 times 4, because well, you and your dad are driving at 4 meters per second. So just get 4 times this thing here. So range equals 4 times 3.16. So that equals, hang on, calculator, clear, 4 times 3.16 equals so 12.64 meters. And the reason why it's meters is because hang on. So here we've got time here. What the well, but the reason why it's in meters is because if you look at this, this 3-point thing here is the unit of this. Remember, we are getting this times this. Okay, the unit of this here. This here is time, and the unit of time is seconds. Okay. Now look at this bit here. The four is really the speed. Speed is meters per second. So now I'm getting this times this, so it gets multiplied to the top. And when it gets multiplied to the top, it will look like this: ms/s. And then the two seconds will kill off each other, leaving you meters. That's why the range is in meters. Okay, but yeah. So the answer to this is 12.61. Sorry, 12.64 meters. So you should place you should place the bucket of water 12.64 meters. Okay, and by the way, you don't have to jump to this. Well, it's best to. It's quicker to jump to this formula. You can jump to the velocity time graph. The velocity. Well, my point is that if you use the velocity time graph method, it will be the same as this. But whenever you have a free falling problem, jump to this. It's much quicker, but it will still work with a velocity time graph. The two will equate with each other. Okay. Well, anyway, the answer is this.